Good evening, class. I need to do one of those introductions where we've ever seen. Let's just go find it actually real fast. I was gonna try to keep these short, but already the coffee's not kicking in. But I'm pretending I'm in front of class, so we're gonna do the thing that I normally do, which is get easily distracted. What is Hitchcock? Intro. I need to do an animated intro like this, right? Like you can't hear the audio, but, and then, yeah, like Travis Foz presents, that would be really good. It'd be really good. And then the shadow walks in, I need the shadow, and then I turn and say, good evening, class. Maybe I'll do that. I'll do that for one of my next videos. Not this one though, because this is literally the first one I'm recording. I think I'm actually skipping over a video, but I had this one downloaded, so let's go. Today we're talking about JavaScript classes. We're going to be talking about how to take the objects that we've learned about before in other classes, courses, whatever we want to say. It gets confusing when we're in programming world, right? When we're in a class learning about classes and we're learning about classes of classes, right? It can get 3 levels deep. But we're going to learn how to take those objects we've dealt with in other programming classes and make them into these things that are sort of like templates. Instead of just dealing with a singular car, we're building sort of the blueprints for cars so we can make as many cars as we want in the future. That's sort of what it is. Classes are sort of the building block of a lot of programming interfaces. If I go out there and I build a game, I will be working in classes all the time because they're a way of sort of structuring my thinking about, okay, what is this set of objects that I'm working with, and how, like, what properties do they have and how do they relate to other things. This is a fundamental concept to get down and to begin to start working with so we can master it in future lessons. So quickly, let's review what we've learned in a previous course. What is an object? Well, an object is a way of collecting variables. It is a way to describe a thing, like a tree or a person or a shoe, whatever it might be. And the way that we describe that thing is by breaking it down into its properties or its nouns, the things that make it up, or you might say the adjectives. But the things that make it up, right? So its weight, its color, its height, its stamina, if we're thinking about video games, its hit points, its speed. But we break it down into those properties that sort of describe it, and its methods or its verbs, the things that object can do. Those two things combined describe a thing for us. So we have properties and methods. When you're sitting down to think about objects or classes, you want to be thinking about those two things. What comprise that particular object, and what can that object do? And does that make sense as an object, or do I need to break this up into smaller pieces as we go along? So in a previous class, you've probably made something like this, and I wish I could get creative with it, but it works, it's concrete, it's boring, I know, I'm sorry. I try to at least make it interesting with the name there. But in the previous class, we made an object that looks like this. Var or let my dog, so the variable name, equal. In JavaScript, our object syntax is the curly brackets. And then we do name, colon, the property that goes with it, height, colon, the property that goes with it, and color, colon, the property that goes with it. So we have 3 properties that describe this dog. It has a name, a height, and it's a brown dog, apparently. So to access that, of course, we use the dot operator. I think we're going to go there, maybe I just sort of assume that you've done objects enough that you can already do that. And then to add a method to an object, so maybe we want our dog to be able to bark. So to add that method, we do it like a property. So we give it a name, like bark, and then we do the colon there. But immediately after the colon, instead of doing a variable, like a string literal or number literal, we write the word function and then the open and close parentheses. So this is something called an anonymous function. It's a function without a name. Technically, the function does have a name. It just comes before, right? The name is bark instead of my dog. But the function itself is anonymous. We're just treating it as data. Open and close curly brackets, and inside of there, all the lines that represent that method for that object. So now we have an object that has variables that comprise that object, and we also have the verb or the thing that object can do. So our dog has a name, a height, a color, and it can bark. Good point right now, if you're watching this video and you feel sort of weak on this, pause and add these two new things to the dog. Give the dog an age and give the dog a run property or a bag property or a bag method. So give it a new method and give it a new property also. So down here in the next set, how do we make our dog actually do the things that we wanted to do? Well, we've got our dog here. We've got its name property and its method bark. And this is the name for the dog inside of our code. So my dog is inside of JavaScript, how we will refer to our dog elsewhere. So down here we do my dog.bark, and that's going to invoke that function. I love that word, invoke. It's going to invoke that function and make the dog bark. Now, when we are working with objects like this, typically we create objects so that the object can change itself. So when someone asks you for your name, you respond with not just some template that everybody responds with, right? Like, my name is genericoid 52. No, you have a name, and so you respond with your name, or at least whatever name you come up with at the time. So like, my name is Travis, so I would respond, hey, I'm Travis. Other people's names might be Andrew, so they'd be, hey, I'm Andrew. Different objects we would expect to respond with different names. Inside the object methods, for us to figure out what are those properties that relate to the object that we're currently inside of, we use something called the this keyword, and that refers to the object that the method is currently inside of. So this bark right here, if I were to write this.name, it's going to refer to the data that's inside of that particular object right there. So this.name is that name there. Krog. So this.name is that name there. And now we can get a result in our console log, this.name barks. Let's go ahead. Again, this is actually called scope also. So we've dealt with scope before in a previous class. I need to fix this chair again. We've dealt with scope before in a previous class, but in this class again, this is the scope for Krog. Great, so that's everything inside the scope. This refers to anything inside of that scope, from the opening curly bracket down to that closing curly bracket there. Let's go ahead and put this into JavaScript and make this a little bit concrete. So I'm gonna hop off our notes here for a second. I'm going to open up our stuff. I've set up a quick application here. I've been a little bit lazy with it, but I just want to be able to show you sort of what this looks like. And I think I'm going to show you, this one actually might be working for us. Sometimes there's a caveat. Let me poke through this code real fast. If you're copying from the note, sometimes you're going to copy in bad data and you're going to have to actually retype the whole thing. I think this is going to work for me, so let's go ahead and look. I'm going to open this with the live server and pop this over here and open up our console. Great, I'm not seeing any errors so far. So let's go ahead and invoke the bark function. So I've got my dog there, my dog.bark, open and close parentheses, and it says Krog barks. So our function's working, it's referring to the this. We changed the name of this dog to a more typical dog name like Fido. Fido barks. Fido is not like a very, I'm sure it's like, you know, it was a common name back in the day, but I haven't seen a Fido for a while, I'll put it that way, in any real life circumstance. All right, so that is anything inside the scope. That's what this is going to refer to. You can also use this to invoke methods. So you could invoke the bark method again by writing this.bark once again. So this is great if we're making a singular dog, but in the video game, for instance, I want to make 1,000 NPCs, right? I want a whole bunch of characters wandering around the city. I'm not going to write the code for every single one of those characters. I'm going to write the code that describes what a character is and then just generate a whole bunch of them based off that template. That's what a class is. I'm going to call this a blueprint of objects. Your reading goes a little bit more into detail here, but essentially what a class is an abstract representation of what an object would be. It is not actually an object, but rather just the template for that object. I tried to break it down here. The idea of a dog, right? If you close your eyes and picture a dog in your mind, that's sort of like the ideal dog there. So it's like, well, a dog, it has a tail, it has 4 legs, it barks, it wags its tail, right? But an actual dog is different. So, I have dogs that wag their tail less, or maybe not at all. And so they're an actual dog. They're a little bit different than the idea of a dog, but they have those capabilities still. So we've got the class, and the specific instance of that would be one of my dogs, Ginny or Rowan or Ada, which is an actual dog, not just the idea of a dog, which when I close my eyes, I think of Clifford, the big red dog. So let's take a look at what a dog class looks like in JavaScript. We're going to use this new class keyword, which you can see here, class dog. And when you're creating classes, typically we uppercase the class. The reason why we uppercase this is it's a signal to yourself and to other developers that this is not an instance, this is not an object, but rather this is a higher level concept that is meant to be turned into an instance or an object. So nothing here is hard-coded, right? Everything here is in the abstract. And we're going to break down a couple of the pieces here in a second. Your reading breaks this down too. But let's break it down here. So we use the class, we use a capital D dog. You'll note that this is not naming a dog or being like a singular dog. It is just dog as a whole, like what a dog is. And inside of here, we have the constructor keyword. This constructor is a keyword. It's an important one. It is the first function that is called when you make an instance of dog, which we'll see on the next slide. This constructor acts as a function. So when we make a new dog, it's going to take three arguments, name, height, and color, just like we had back here for dog, which had a name, a height, and a color. And it's going to store that inside of the dog object. So this.name, this.height, and this.color. If we go back 2 slides and we look at the instance of dog that we had here, this.name, this.height, and this.color. And we're accessing this.name there. We're doing the same here. We're just setting those properties rather than getting those properties. So how do we make an actual instance of a dog or an actual concrete dog from the template of a dog? We use the new keyword, which you can see down here. So these two sets up here will make me a new dog. And let's go ahead and sort of inspect this a little bit more in our code. I'm going to copy this. Not all that, just the code piece. So I'm going to copy this. I'm going to hop back here. And I'm going to paste it down here. You can see in my code editor, I've got these little squares. Those are bad. Those will cause all of my code to break. So keep your eye out for that if you're copying code from my slides. You might get something like this. And me being the type of person I am, code cleanliness and readability is important since I have the open and closing curly brackets there. I'm going to tab all the code inside of there also. I almost always fix my code up right away so I can read it. Now, I'm going to leave both of these in here right now to show you how they're interoperable, but that means that I can't have 2 var my dogs because I'm going to overwrite this version with that version. So I'm going to name this one my dog 1. And I'm going to name this one my dog 2. So first we go through, we make our concrete object. The second part, we make a class and then make an instance of that object. And let's look at what the differences are between the two. I'm going to do a console.log my dog 1, which again is the dog I defined through the object syntax. And right beneath that, I'm going to look into my console and debug my dog 2. And let's look at what the differences between them are. So let's go back and refresh that page. I think it refreshes automatically. And let's also get our developer console open. So the results of our 2 logs, 22 and 23, we can see here. Let me pull this over just a little bit so we can see 22 and 23. We can see that they are objects. They have the little curly brackets around them. They each have a color, a height, and a name. Color, height, and a name. The only big difference here is that while our first one just has the curly brackets around it, the second one has this dog keyword in front of it, which is just telling us that it's the instance of this particular class. So as I mentioned, all we're doing with the class is that we're making a variation of my dog that makes it easier for us to do this. And when we're to make an object, and the reason why we do this, we make classes, is because oftentimes it's easier to think about how our program is going to work in the abstract, and then build the implementation of that, and then create the instances of those abstracts and connect them together. When you're sitting down to diagram this out and to whiteboard your applications, you're oftentimes thinking in terms of, okay, just what are the names, like what are the properties it needs to have, what are the methods it needs to have, and I'll get the data into that later. So we oftentimes work in that particular method. All right, so we've got our 2 dogs there. Let's go ahead and make my dog 2. Let's get a function. I'm certain to bet that that's the next thing I'm going to be doing in my slides. It's not like I look at my slides before I keep teaching. I just kind of expect it. So how do I add a method to a class? Well, unlike how I do it with an object where I have to sit down and make a new property and then do an anonymous function, I simply write the name of the method I want, and then if it has any arguments inside of there, and then put curly brackets beneath it. So here's the exact same method that we had in our prior object, but we're doing it inside of a class instead. And to invoke a class method is very similar as well, right? We've got this bark, and we say console.log this.name barks, and we just do mydog.bark. So let's go add a method to our class code. All right, we're gonna add a method, and it'll be very similar. It'll just be console.log this.name slash we'll do woofs instead. And let's go ahead and make mydog2 bark. So mydog2, which is the one we're basing off the class, we're instantiating. Mydog2.bark, open and close parentheses, save. Refresh that. We're actually getting it already. Giselle woofs. So great, super exciting, right? We've made a dog, we've made a template for it, we've made it woof. Now that you've seen that this is allowing me to create the exact same version of that, I'm going to go ahead and delete this. I'm going to delete the object version and just work off of the class version. So before I move into the last concept for our object-oriented, our classes, I want to show you why this is super important. Oftentimes when you're programming, you will be making classes, and you won't be making just one instance of a class. You might be making multiple instances of a class, and you want them sort of all hooked up the same. So there, mydog2, we're going to do mydog3 equals new dog. Andy's a fun name for a dog, I guess, right? Height, I don't know, it's a very tall dog, 400, it's a very big dog, and it's a red dog. So I guess maybe it's Clifford, right? Clifford with 2 F's. Awesome, and so now we've got a third dog. We can make it bark also, mydog3.bark. And Clifford woofs, right? So it's very easy now for me to create as many dogs as I want. Do I want 400 Cliffords? Sure. Where I equals 0, I is less than 400, I plus plus. I don't know why we would particularly need this, but let's go for it. We're gonna have Clifford bark 400 times. So Clifford woofs 400 times, right? Or we could also do like Clifford plus number. So now we have 400 different Clifford barking. So this is oftentimes why you make classes that you want to work in the abstract and make it so that you don't have to worry about any of this. A lot of the times you'll be working with code that other people have written the classes for you, and all you have to do is create the instance of that class, and you sort of assume that the class does its job and that you just have to use the application programming interface or API that they've defined for you. So like, yeah, cool, I've made a dog for you already, student. All you have to do is use that dog's methods now. So you provide its name, you provide its height, you provide its color, you can make it bark, you can make it run, you can make it wag. You don't have to worry about how I implemented that. I did that in the abstract for you already. So last concept here that I want to show to you, we're not going to be using it particularly much in this class, but it is an important concept to be exposed to, is, in fact, there's a lot of things in this class that like I need to show to you because they're important concepts. We're going to practice them for a bit, and if you move on to another context, you will be using it all the time, but we might not actually be using them quite heavily in this particular course. So in object-oriented code, there's this concept of class inheritance. So oftentimes you'll find yourself writing code where you'll be working with something that's a more specific version of something else. For instance, I keep going back to video games, which is a really awful example. Let's do clothing. In clothing, right? Clothing in general is something that a human wears, so it probably has like a size that goes along with it and a material that goes along with it. But then there's also specific instances of clothing, right? Pants are very different than shirts. While they can both be made out of denim, I don't know if you'd want to wear a denim shirt. One of them has 2 arms, one of them has different legs, one of them has a neck hole. I don't even know what all the clothing terminology are. But they both are instances of clothing. So you might want them all to be operating like clothing, but then treat some of them as pants and others as shirts. We're going to stick with the really boring animal example. For us, every single animal, of course, might have a name, weight, and color. So we could base our sort of base template class of animal, and then have dog be a more specific version of animal. So here's our base template. There's a name, a weight, and a color for animals. And then we're going to make dog sort of extend the capabilities of animal, because not every animal woos. In fact, only a dog really woos. The way we do this is that we define a second class called class dog, right? And then we use the extends keyword and tell it which class it's based off of. Inside our constructor, we want to take all the information we had from our constructor before, and we use this keyword called super, and we pass along these constructors, so name, weight, and color. What super does is it invokes the constructor the class is extending. That means that we're extending animal. We are invoking this constructor inside of animal, and actually simultaneously setting this dot name, this dot weight, and this dot color, and then also this dot kind. So let's get those 2 in there and see how this makes our dog work a little bit differently. So I'm going to make my class animal. And then I'm going to make my class dog. See that square there, it needs to go. And so I can come down here, and it's fine for me if I wanted to make like a let animal ex equal new animal. This would define maybe any animal. Weight of 10 with a color of green. But that's all my animal really would be. However, I can also do a let a dog equal new dog, and we're going to send along the name, which is going to be Rex, and the weight, which is going to be 45, and the color, which is going to be how about black. What am I missing here? Oh, I closed it too early. Okay, and then let's just inspect that dog real fast. We'll do a console log a dog. And we'll also make a dog bark. So we come back here and look at our console from the operation here. It says Rex barks, so it's still doing the bark here, that this dot name is working. But you'll note that nowhere inside of the class dog do I set name. And that's because the name is set through the super. So the name that is defined here, that comes in through this constructor here, is then passed up to the super method, the super constructor, such a cool word to say, passed up to the super constructor up here, and then set is this dot name here. They're all working on the same object, however. So when I invoke a dog.bark, it's going to find that name. So if you're sitting down and you're looking for a way to how do I practice this? How do I get a little bit better at this before I hop into the code? Find something that you can make your own class of. I don't know what it is, but everybody has something in your life that you can define. I'm sitting here looking at Funko Pop figures, so maybe they're toys, maybe they're books, maybe they're CDs, maybe it's music albums, maybe it's plants, maybe it's clothing, maybe it's cars, maybe it's shoes, maybe it's basketball players, maybe it's video game characters in your favorite MOBA. I don't care. Find something that you can break it down into a set of properties and methods of that object, and make a class for it, instantiate that class, invoke some of the methods, and then try to make a subclass of it, extend that class into something else. Just play with it for a little bit. It doesn't have to take too long, 10 to 15 minutes, I would say maximum, to practice this stuff. But this is good stuff to have. As I mentioned in the middle of this, we're going to use this a little bit in this class, but this is the baseline thinking that you will see implemented in Unity 3D, in Unreal Engine. If you hop into Godot, you'll be doing this kind of stuff. If you're hopping into, say, oh my goodness, what is it? C#, Mono.net, the backend framework for stuff, or Java, doing sort of business-oriented backend framework stuff. This is exactly how it all works. They're based off of classes. They're based off of inheritance. Knowing how this thinks and operates is going to be very critical for you to be able to be more fluid and proficient outside of the JavaScript world. That's why I'm introducing this particular concept for you.